Assalamu alaikum. Today we're going to talking about this rebar placement, cross-section rebar placement process in beam. In previous video, we are talked about longitudinal rebar placement in beam, and now placement process the cross-section bar, stirrup bar, this beam. So let's start. If we just open a dynamo player and select any beam and just run it, select another beam, as you see, all stirrup rebar place automatically in quickly in this each and every beam structural framing. Okay, so we can use this process to set up rebar easily with this automation process. Also, we're going to create this rebar with dynamo player, dynamo, and going to and after that start this, and every time we can start this script with this dynamo player. So okay, no more another talking. So let's start then how to create this rebar. So first of all, open this manage ribbon bar and open this dynamo, click it. Okay, so this is the dynamo interface. So click this new. So first open create a node. Bring this node which is select model element. Right click on your dynamo interface, select model element, not model elements. This is the model element because we have to select single object. Just minimize this window and for show this Revit window, and select this model element node and then select this beam, any beam, and we can see the beam family shown in dynamo interface. I just change the manual automatic to manual for now. So select model element and then connect another node. So this is the beam family. In beam family data shown in this dynamo interface. Then we need to show the beam geometry in dynamo interface. So select element.geometry. dot geometry. So this is the beam geometry, and now create open bring the bounding box. Bounding box by geometry, connect to this one. Now bounding box to cuboid, bounding box to cuboid, because directly bounding box not shown in this dynamo interface. To show a bounding box as a geometry, so node is to cuboid. If we off this preview geometry, we can show the bounding box to cuboid. So we can show the bounding box to bounding box geometry to cuboid in this dynamo interface. So then create. Okay, so as you see, this is the preview geometry, the directly beam in beam geometry, and bounding box shown in this hold this beam, and create a geometry from bounding box in this way. So after cuboid, from this cuboid, find out the center point. Centroid to cuboid. So this is the geometrical centroid point. Control I for to show as a X-ray mode. Now get the rotation geometry. Geometry rotation dot rotation. So geometry dot rotation. Very strange. Where is the rotation? Or rotate. Okay, so this is the rotation node, rotate origin geometry this is the desired node. We need to use this node. So the geometry is this one, and the origin should be the centroid point. This is the origin point, and axis will be the z axis. So z axis and degree. Oh, okay. How can we get this degree? We can get this degree. We need to find out this element, which already select from this node. So get rotation. So get rotation node can be found in Genius Loki package. This is the custom package. We can download, search for package. From this search for package, we need to, before search for package, we need to connect the internet. Okay, the connect to this element, and degree is the if we connect the run it, you can see the rotation angle shown in this get rotation node. So now, before connect to this degree, we need to change the rotation position. Right click on your dynamo interface, and in this code block, just text variable multiply -1. Now connect to this degree. Okay. Okay. From this geometry, try another bounding box. Just copy this bounding box, Ctrl C, Ctrl V, and connect to this rotate geometry, and apply another cuboid. Ctrl C, Ctrl V, and now try again this rotate geometry, Ctrl C, Ctrl V. So now geometry is this cuboid, and origin okay, or axis is also okay, and degree should be the main positive degree. If we run this, run it, as you see, we can get the main geometry, where rebar should be placed in this geometry. So I just turn off this geometry cuboid. So after this, okay, now from this node, first we need to decide where rebar place rebar should be placed in this beam. Rebar should be placed in this orientation. From the outside of the beam surface, the offset should be somewhere like this. It could be the 25 millimeter or something else, or 30 by 4 or 40 millimeters. So first offset the surface from this main beam surface. So now this is the totally solid geometry. We need to explode this geometry to convert a surface. Explode. From this solid geometry, we can get this surface, 6 surface. Now let's flatten. After that, before offset this outer surface, this all surface should be joint. So poly surface by joint surfaces. Poly surface by joint surfaces. So poly surface created. Now create a offset. Surface offset. Connect to this surface, and distance should be say minus 40. Now run it. Okay, great. As you see, the main beam is this one. The offset within this beam, main beam. This is the inner beam, inner geometrical form from this main beam geometry. Okay, now from this inner geometry form, we can place rebar with this inner beam geometry surface. Now again geometry explode. I just save it, say, for safety. File could be crash anytime. Geometry. Okay, so from this surface, the geometry explode give us as a solid. So now Export again. Now we can get a surface. Now flatten. So from this flatten, get surface area. Get surface area. All surface area shown in this list. So now get minimum item. And list contain. Why we use this surface area and list minimum item? Because from this all surface we need to pick this surface. We need to pick this vertical surface, not this one, not this one, not another direction, not another direction. So we need this one also in opposite side in this one. Okay, so that's why we need to isolate this small vertical surface from all surface of this beam. So the get minimum item. Now list contain. List contains, and list should be this one. Now after that boolean mask, connect to this bool mask. Okay, now just run this script. For now we can get the one result. I need to result this sixth object. Now let's sing longest. Okay, so connect to this flatten list and now run it. As you see, we can get the isolate surface. These two surface is this one and also this one, and other surface isolate this one and this one, four side. So now we can use this in output data. So get first item. Get first item from in list, and now perimeter curve, surface perimeter curve. All curve should be separate in this surface. We don't need this type of curve. We need to join all separate curve. So poly curve joined by curve, poly curve dot joined curves, and connect this one and run it. Okay, surface patch curve. Actually, we don't need this one. I just place another site for now. We can use this one and also this one. Before place rebar from this curves and also surface, we need to get another we need to find out the another value for beam length. So get parameter value by name, and the parameter name is cut length, because why we need this cut length, because we need to, if we I just show you, if we rebar place in this orientation in this direction, so bar should be placed in this direction in whole beam length. So length should be find out this internal beam length in this Revit file. So length should be, if we select this beam, and we can get this cut length, this one. So we can get the we need to find out the value and use it for this stirrup rebar placement in specific spacing. And so this is the node which can be found the parameter value. So right click on this, double click on this interface, and bring this node code block and write it parameter name cut length. The element should be this one. Okay, we can get the length. Now the placement time. The placement process will be the specific node which we can get the custom package structural design. Say create from curves, this is the structural design custom package, and we open it. there is some input node should be connect rebar style, rebar part type, rebar hook type. Okay, so now get it. Now connect the rebar. So first rebar style. Okay, we can get the rebar style should be from this one. So rebar style, standard rebar bar type, start hook orientation, rebar hook type, and the host curve is the curve is this one, and host element from this element. And what is the vector? Vector should be the because vector is this bar stirrup bar placed in this direction. So we can get the vector from this curved line and create surface. Surface we already found, and from this surface we need to the normal position in this direction, which is the surface normalization. So if we bring the specific node surface normal at normal at parameter. So u and v should be create code block and 0.5 always place in mid position, and surface is this one because so this is the surface, and vector is connect this one. And now if we run this script, we can get a rebar place on this beam. Before run this script, we have to connect another final node to create spacing. Set layout as a maximum spacing, so which is set layout for mesh layout. So which one should be used for spacing? Set layout as maximum spacing, this one. So connect rebar from this one. Spacing will be say 200 or 100, and we can get the array length say x minus 100. Actually we can use normal side true, so this is the script how we can place the rebar. Now another thing, connect this node. Now run this script. Okay, run it. Great. As you see, the stirrup bar plays automatically in this beam. So we can use any beam with to use this script so quickly. Select this beam, select this beam, great. Okay, we need to use this script with dynamo player. Just right click on this select node and use input. Now open a dynamo player. Now open this demo and now select any beam, any angle or any orientation, place any orientation, beam place in orientation, any orientation, just select this beam and run it. See the stirrup bar place automatically so quickly. Okay, so this is it for today. So we will see in next video tutorial. Thank you.